What we have already done up to now, we have actually already installed and configured PX4. Then we have installed ROS1 and ROS2 parallel. We have configured catkin workspace. Parallel to catkin, we have configured Colcon. Colcon is something very important actually before we can actually do any package building for ROS2, because in ROS2 we are using Colcon. So for doing this Colcon stuff, what we need to do is that we should go to any directory we want, and then we need to create actually a source folder in it. We have created a source folder here. Then actually we have to, before we can install this, we need to run this command to just set up some tools, and then this is the official repository of the Git. Actually we should copy it, we come back here, we paste this here, and if I enter, it's gonna install something here in source folder here. So I have installed multiple things, but here actually you can see PX ROS2. So this is communication protocol. Especially now we need to build up this package. So there are multiple different ways to build up this package, but we are using this here, which is Colcon build package select PX4. Let's say like that. If we do this, in the end it's running the workspace. Okay, we have trying to build everything from source, but we should only, okay, this is only message actually, and it says that it's successfully built up this. So ROS message is actually the requirement or dependency. You can also just git clone PX4 and PX4 messages. It is official repository also there. You can just check. I can maybe show that one. I'm not sure. I can just go to GitHub, and then I can write PX4 messages. Maybe here. Jump to that. Yeah, this is the. I should come here. I should go here. And in this source folder, make sure it is in source folder. I should git clone and this package. After you do this, you should see actually these packages, PX4 and this. And for this repository to build up, this is the dependency. So we have just seen that we have built this now. Now we can run this package in the Colcon. So to test that communication is successful or not, we need to run the PX4. PX4 is somehow is not dependent on the communication network for ROS2. It is same for that means, and which means it is same for ROS1 and ROS2, and we can run it from and call it from any directory like that. If I call this here, it should run for some time, and after that it should open the gazebo, blah blah blah, and everything ready to shoot. Okay, great. For example, like that, we can also test everything working or not. In another terminal, in terminal number 2, actually, what we can do is that we can write this stuff here. To just make sure, I can write this micro XRCE agent on port 8888. When I run this, you can see that it's creating all different stuff to make sure the communication. Now it's showing that the communication is successful, and I can also see here that it's creating a complete stuff here to broadcast some messages, which in micro DDS client as well, which means our micro client now successfully linked there, and whatever hierarchy or message we have seen in the document lately, I don't know where if we have it, but I don't know. This is the architecture here, and we have seen this architecture. Now this thing is running, this thing isn't running, and back in the ROS is running, ROS2 node, and now we can customize this stuff easily. So to make sure that everything is working, we can just ROS2 topic list here, and now we can see that we have some topics here. So it is beautifully connected here. Now what we can do is that we can control our drone with help of off-board node in the Python. We can do this. We'll do this in subsequent lectures, and we can do this in subsequent tutorials, that how we can take control of drone with help of off-board controlling, how actually we can customize the messaging in service, how we can control in more meaningful way, like go to goal, go to special goals, waypoint publish, and how we can actually get the odometry of or odometries of drone and orientation of drone, how we can do path planning, navigation, trajectory planning, and all those stuff, which is actually more meaningful in indoor environment, GPS lost environment. So this is more practical, because in indoor setup normally we don't have the complete GPS signals. Yeah, we're gonna build this. Stay tuned. Thank you very much for watching. Bye.